In aqueous chemistry, there are two types of situations you have to deal with in doing calculations initially. First of all, you've got to recognise the kind of ionic salt that you're dealing with. For instance, in this case, silver chloride, you know that's going to split up into one ion of each. For instance, in here, silver and the chloride ion. That's a 1-to-1 ratio. And the same would be true of barium sulfate. It would split up into a barium ion and a sulfate ion. And those are reasonably straightforward. Then there's another one where you'll have a 1-to-2 ratio. And that means something like magnesium chloride or calcium hydroxide. You'll get one calcium ion and you'll get two hydroxide ions. With sodium sulfide in this situation, that would be a 2-to-1 ratio. Now, for these two, really the calculations and are very, very similar, so we consider them, they basically use the same mathematical expression. Now when we look at the Ks expression here, Ks equals the silver ion concentration times the chloride ion concentration. When it's at equilibrium, those two values are going to be equal to S. So if we know the solubility of silver chloride, that means this silver ion concentration is going to be equal to S, as well as the chloride ion. So as Ks equals S times S, we can say that Ks equals S squared. Okay, and on this side, we're going to have the solubility of calcium hydroxide is going to be equal to the concentration of calcium ion, but it's going to be twice the hydroxide ion concentration, because for every one of the calcium ions you get two of the hydroxide ions. So when you put that into the expression, okay, there's a 2 there, squared, and that becomes 4s squared, and it's times by s, I mean this s you're multiplying it by, and that equals 4s cubed. Now if this little bit here confuses you, you don't have to worry too much. All you need to know is in a 1-to-1 ion situation, on this side for instance, Ks equals S squared, and on this side, if it's a 1-to-2 ion or a 2-to-1 ion, Ks equals 4s cubed. Now, just so you have some awareness of what this actually really means, the Ks value is a constant. That's just like any equilibrium constant. It doesn't change except if temperature changes. S is the solubility. It's how much of the solid will dissolve in a solution. And on this side, again, it's really the same thing. Ks is a constant for the solution, and the S value is the solubility, how much dissolves in 1 litre. Okay? So these values are important for doing calculations. Okay, now you are expected to do some calculations, unfortunately, and one of the most common things students get confused with is what they're actually trying to calculate. At some points they think they're trying to work out the solubility, and some they're trying to work out Ks. Be very careful in reading the questions so you have some confidence. If you're asked to work out Ks, you're being asked to work out the equilibrium constant. Now, Ks is either going to equal S squared, which means you're going to have to find the solubility and just square that number, or Ks is going to equal 4s cubed. Okay? In which case you're going to have to find the solubility, cube it first, and then multiply it by 4. You do not multiply it by 4 and then cube it. That will give a wrong result. Okay? So you cube it and then multiply it by 4. Okay? So which one do you use? Well, if you're being asked to find the Ks, you just have to recognize initially, is it a 1-to-1 ion or is it a 1-to-2 ion? Now with barium sulfate here, there's one ion there and there's one ion there. So in this case, if you're being asked to work out the Ks, it would be Ks equals S squared. Lead iodide is a lead ion and there are two iodide ions, so that's a 1-to-2 ratio. So that means you've got to use Ks equals 4s cubed. So you may be given the solubility as I've given it to you here for sulfate. Sorry, for barium sulfate. So all you've got to do here is square this number, and you're going to work out the Ks value. In this one, you're just going to have to cube it first and then multiply it by 4. It's important to show your working, because if you make a mathematical error, you can still actually get a reasonably good score in a question. And if you've shown the calculation you're going to use, like Ks equals S cubed or Ks equals 4S cubed, and you've shown some of the values, they'll still give you some credit. Whereas if you just show an answer, they can't give you credit for that. Okay, now the second kind of calculation is if you're asked to calculate the solubility. And again, you've just got to recognize is it a 1:2 or a 1:1 ratio. Now in this case, obviously it's a 1:2 ratio. And as Ks equals 5.04 times 10 to the negative 6, you're going to use this calculation because it's 1:2, Ks equals 4S cubed, which means you've got to divide this number here by 4 first and then find the cube root. Okay, remember the way this would have been worked out initially would have been 4 times S cubed equals Ks. So it would have been cubed for it first and then multiplied by 4. So you're going to divide by 4 and then find the cube root. Make sure you're okay at finding the cube root button on your calculator. Now the answer to this one here is going to be 0.0108. That's moles per litre. Now Ks values like this, they have no unit. It's a ratio. 0.0108, the solubility, is a concentration. It has a unit, moles per litre. Now in the copper carbonate case, that's a 1:1 ratio, so you're going to use Ks equals S cubed. So you're going to square, so S would have been squared to get Ks. So you just need to find the square root of this number, and in this case it's going to be equal to 1.44 times 10 to the negative 10 moles per litre. Okay, so just take care you know what it's asking you to do. Often students get these mixed up. If it's asking you to find the solubility, all you're going to have to do is either take the square root of a number, if it's a 1:1, or if it's a 1:2 ratio, you're going to have to divide by 4 and then take the cube root, and that will give you the solubility. Okay, now they do get a little bit more awkward, so watch the next one to feel more confident on how to do solubility in Ks calculations.